In this tutorial, I will be showing you how to set up a master-slave type program between a Raspberry Pi and an Arduino using a NRF24L01 Plus transceiver. This tutorial is following up on the previous tutorial that established a Hello World message being sent out by the Arduino, and the Raspberry Pi simply receiving that message and decoding it into a string. Now we want the Pi to be the master that tells the Arduino to do something. The Arduino thinks about it and does something accordingly. So I'm going to this receive Arduino.py file that I created in the last tutorial. I'm going to save a copy of this as send receive Arduino.py. Oh yes. And a lot of this is going to stay the same because there's no need for it to really change. One thing we are going to have to do, though, is open up a writing pipe. If we are going to be sending data out, we need to open up a writing pipe. And we are going to be listening on, or we're going to be writing on the 0 address here, the first address in our pipes, and we will be reading on the second entry in our pipes address. So keeping that in mind. And we will not be listening because this is going to be the master. The Raspberry Pi here will be the master, so it is not going to start out listening, and it is instead going to start out executing commands. Now, what is that command? Well, the command we're going to, because I don't have any sensors or anything connected right now, is just going to be a simple like a get the string, whatever the string is. And so we are going to have to create a list sending out the string command of what it is that we actually want to transmit. Now, we have our payload size set to 32, and this is the same on the Arduino as well. To make things nice and tidy, it's good if we append zeros to any leftover bytes that are being unused, and we'll let the Arduino figure that out. If you just send this, you will sometimes get an issue where it duplicates or whatever. And you definitely need a null byte on the end of whatever message you are sending. And you can't send that in a string because a 0 in a string is not necessarily 0 when it comes to bytes. So what we're going to do is, for whatever length is left over from our message that we're going to send, so while the length of the message is under 32, because we are sending 32 bytes, we're going to append to our message a 0, and that will be like a true 0, a null byte 0. Now, sometimes this will time out, and if we are going to be sending out a message and then right after the message is sent, we're going to wait until we do something, well, we might never get like a return message that acknowledges that we actually received it because of the nature of the Arduino. So what I'm going to do is I'm going to set up a start time here so that we can have our own timeout programmed in, and then we're going to send out our message, and our message would be get string. So we can say send the message, and that message is message, which would be get string. And then, so we've sent this out, and now we can start listening. So this could be something like, hey, get the temperature, but in this case it will just be get the string, whatever string is stored on the Arduino. And then we are going to listen. So we're going to wait until something actually shows up on the radio. So we will also do a check here. So if the time is, if the total elapsed time is greater than 2, then we will break out of it because, here, let's just get a print statement in here, because we timed out. And then I'll just carry on with the rest of the code and not get hung up in this loop here if the Arduino were to have a burp or something like that upon startup. So we've sent out our command, we wait for something to show up, we will then get a received message from the Arduino, which will then be decoded into string characters. That can stay all the same. What we're going to do at the end here, though, is we're going to prepare the Raspberry Pi to execute the next command. So we'll stop listening, because we have started listening and you can't send a message when you are listening. So we will stop listening, and then we will go to sleep for 1 second so that we're not spamming the Arduino constantly, and then it'll go through the loop again saying, setting up a new time, sending out the message of get string. Very simple example. So let's save that. Now that we have this set up on the Raspberry Pi, we're going to have to set up our Arduino to actually receive this message, interpret it, and do something based off of it. So again, I've been programming on my Mac side here, and we have the file send. So this just sends hello world, and that's obviously not enough. So I'm going to save this as a new file called send receive, because we will be sending and receiving on the Arduino now. Now, if we're going to be sending and receiving, how do we verify that we're actually receiving something on the Arduino? Well, short of it actually completely working the way we expect, another way we could do this is we could set up a serial connection. So we're going to check if a serial connection is available to us, and then we will begin our serial connection, baud rate 9600. So this way we can check the serial monitor and see what we're actually getting in. We're going to want to set up the radio before, just like before, and we're also going to, after setting up the opening up the writing pipe here, we're going to have to open up a reading pipe, as you can imagine. So we're going to have to specify an address for our reading pipe, and our reading pipe address can't be the same as the writing pipe. Instead, it has to match what is on the Raspberry Pi here, that is this address here. So over on the Arduino end, we have this value called pipe, and we are going to populate it with 0x E8E8 F0 F0 E1LL. And then we'll just open up, let's get this out of the way, open up our reading pipe. And what is that pipe? That pipe is the pipe, the one and only pipe. We'll enable our dynamic payloads just like before, and then we'll power up our radio just like before. The main loop here is definitely going to change. It's going to change quite a bit. So let's get rid of everything that's in it and just start over again. So right now we are going to be listening. The Arduino is going to be waiting for a message to be sent out from the Raspberry Pi, and then we will just print a line here saying starting loop radio on, so we know that it's actually working and we're getting something out of it. And then we will populate an instance of our received message. We will continue going through this loop, and we will check each time if the radio is available, so this is similar logic as what we were doing before. And if it is available, excellent, we're going to read whatever is being sent over to the Arduino, and we're going to populate our received message, and then we have to specify the size of our received message. It'd be nice if we actually know what that received message is, so let's print it through the serial here so we can print our received message. And then, just so that we know what's going on, let's print line and say turning off the radio, because right now we have received a message. We know that we need to do something based off of it, but we can't send out data if we are still listening, so we will stop listening, and then we will create an instance of a string here. And the string will be like a string version of the received message, since the received message is an array of bytes. And so we will convert that into string message, and we'll be pulling our data from the received message. And then we will create another if statement here, and this will just check to make sure that our string message that we received is equal to a command that we recognize, and that command is getString. And if it is the command that we recognize, excellent, let's print a line saying here, looks like they want a string, because it's telling us to get the string, right? And so they want a string from us, and so we will give them a string, and that string will be equal to, and this is similar to before, hello world. So this could be like sensor data or something if you wanted to program that in here now, or call on a function that creates your sensor data. You could set that up. I just, since we don't actually have sensors, we're not doing that right now. We're then going to send over our text, just like before, along with the size of the text, and then we can have a dummy print statement in here that says we sent our message. All right, and it's going to cycle over and over and over in this loop. And so just so that we don't, we can have a little bit of a delay here so we don't spam up the serial monitor too quickly that we don't actually see what's going on. And now we have a tenth of a second delay here. So let's give that a save and let's upload that to our Arduino. Oh, sorry, this is a typo here. This here is not square brackets, this is curly brackets. In our reading pipe here, we want to give it a 1 before we give it a pipe as well. And we are missing a semicolon after this print statement here. So lots of typos in C, and that's why I prefer Python, is because I make fewer typos. So we'll upload this. So we're done uploading now, and so what the Arduino is doing is waiting, should be waiting. So there we go. So we have our starting loop radio on, opening up the serial monitor here, so it is just checking, is there anything coming in? And it is waiting, and it is waiting for our Raspberry Pi to send over a message. Well, how about we send over a message? So we have our Python script here, send receive arduino.py. To execute that, sudo python3 send receive arduino.py, and there we go. So we're sending over the message, get string, and then we are decoding it to hello world. Perfect, it worked that time, right? So like it didn't initially for some reason, and then it started actually receiving our message hello world, and we're sending out get string with a whole bunch of empty bytes afterwards. We receive our bytes in and we decode our bytes into hello world. So that's what's happening here on this end, and then here on the serial monitor you can actually see here we print get string, which is our command, and then we do whatever it is based off of that message. So there you have it. Back and forth communication between a Raspberry Pi and an Arduino, where the Raspberry Pi is making the Arduino actually do something using Python. I hope you enjoyed this and have yourself a good one.